peeps? This is lesson 112, ratios and side lengths of right triangles. This lesson introduces something that is brand new that actually pays dividends in trigonometry. I wish that you were here with me because we can do some cool things in the classroom to help understand this lesson. So it might be a little weird, but you're a boss, so hang in there. Here we're going to find the ratio of the length of the side opposite angle A to the length of the hypotenuse. Express the ratio as a fraction and a decimal. Okay, so, whoa, let's take a look here. We're going to find the ratio of the length of something. So the length of what? Well, the side opposite angle A. This is going to be tough to understand for some of you. Some will see, okay, I got it. Here's angle A right here. Imagine that you're in a triangular room and you're standing right there in the corner of angle A. Well, if you're looking across the room, you're going to see that this side right there is opposite of where you're standing, completely on the other side of the room. So, I want the length of the side opposite angle A, which is 3 to the length of the hypotenuse. Well, the hypotenuse is easy to find, it's 5. So there's the ratio of those two sides. Now, as a decimal, we know that it is 0.6. Done. Next one, find the ratio of the length of the side opposite angle X to the length of the hypotenuse. Okay, be thinking about where that is. What is the side opposite of angle X? Well, again, here's our triangular room. You're standing right there on this corner. What's opposite of angle X? Opposite is all the way across the room. Boom, 6. The ratio of the side opposite of angle A to the length of the hypotenuse. The hypotenuse is 10. There it is. As a decimal, 0.6. You're learning something valuable again for a small little trigonometry unit that we're going to do next year in Algebra 1. Find the ratio of the length of the side opposite angle R. Okay, we're going to focus here first. Opposite angle R. Here's angle R here. We have to go across the room. That's going to be 1. However, curveball, the length of the adjacent side. So what does the word adjacent mean? It just means next to. So here's R, and you're in this corner. You're next to 2 walls. You're next to this wall right there, which is called the hypotenuse, but the other wall is called the adjacent side, ADJ. So we need to find what the length of that wall is. Well, since we're not given the length, we have to find the length using the Pythagorean Theorem. So here we go. A squared plus B squared. I'm saying that the adjacent side is side B equals C squared. Okay, I'm going to let you work through that quickly. This is 1 plus B squared is equal to 4. Take away 1 from both sides. B squared is equal to 3. And of course, take the square root of both sides. And so the length of our adjacent side is root 3. But remember, we don't change it. We don't know what root 3 is going to be. We don't need a calculator. So we just leave it as root 3. So the ratio is 1 over the square root of 3. And we leave it like that, and we're done. Try this one on your own. Okay, the angle B right there, what side is opposite of angle B? Well, you go across the room, boop, 5, and the length of the hypotenuse, you probably needed to pause to find the length because I didn't give it to you, but the length of the hypotenuse of this triangle is 13, so 5 over 13. Next. Again, pause if you need to do it. Okay, find the ratio of the length of the side opposite angle Q. Here's angle Q. This is the side opposite. Well, I don't know what it is, so apply the Pythagorean Theorem to find this guy right there. I know this is the hypotenuse, so I'm going to skip a step and go straight to this. 17 squared minus 8 squared, which is going to be 289 minus 64, which leaves us 225. Now, can this side length be 225? Of course not. Remember, we got to take the square root at the very end. The length here is going to be 15. So back up to the question. The length, the side opposite, which is 15, and the length of the adjacent side. Okay, so what's the adjacent side? Okay, you're standing in a room, you're right here. You're next to that wall, and you're next to this wall. Well, which of those is the adjacent side? Well, this is not the adjacent side because it already has a name, the hypotenuse. So this is the adjacent side, 15 to 8. Boom, done. Okay, again, pause the video, give it a shot. Find the ratio of the length of the side opposite angle Y. Okay, here we go. Here's Y right there. Opposite is 4, and the length of the hypotenuse. So carefully taking a look here, the hypotenuse is right there. I'm going to call it side C. You need to apply the Pythagorean Theorem to find the length of side C. So I'm going to go again quickly. 7 squared is 49 plus 4 squared is 16. That gives us 65. Don't forget to take the square root. What's the value of root 65? We don't know. So leave it right there. Boom, done. Here, assignment, I'll pop it up.